Hey guys, so the lecture that I decided to attend was Estimating Our Energy Predicament, where the lecturer discussed briefly how everyone can use estimation techniques. In short summary, the lecture was about how we are able to make basic assumptions in chemistry and physics that lead to actual data and ultimately predict possible outcomes for the future, such as using physics to predict the end in economic growth by understanding that a cap in physical growth is directly related to a cap in economic growth, and so major adjustments can be made. This sparked my interest because the future of fossil fuels and global warming have always been a prevalent topic throughout my high school and college career, and has always been something I feel should be of importance. Something I learned that I already knew was that the rise of carbon dioxide levels cause a rise in increased temperature, but I did not know that this was something we should have expected, as it was no surprise that 1 gram of fossil fuels produces 3 grams of carbon dioxide. This same assumption can be made for fossil fuel history. Several examples were discussed on alternatives to fossil fuels, ultimately leading to the cheapest go-to solution being lead-acid batteries. Except the amount needed would be more lead than globally existed, so therefore this lead-acid battery is not a good solution. In all, fossil fuels are hard to beat. Another topic discussed was that guesstimation and using Fermi problems can give answers to unanswerable questions, such as how many kids are laughing so hard milk is spilling out of their nose right now. This can be solved by determining the amount of people that live in the world, breaking that number down to the vulnerable age in which kids would spill milk out of their nose, and also approximating how many adults have had this experiment. You would then make an assumption that this has only been a one-time life event and that the spilling of milk out of their nose is only a duration of 5 seconds. Using all of these assumptions and approximations, you can ultimately direct you to a valid answer. By using reasonable assumptions, perhaps by statistical evidence to come up with an answer to problems that we might not ever know the precise answer to. Fermi problems are a useful method because oftentimes they lead to estimations that are often close to correct. This also sparked my interest as well as I decided to look up other questions that fit along the lines of the Fermi problem. One example was how long would it take to count 1,000,000? Or the classic Fermi question, how many piano tuners are there in Chicago? With all of these questions, you can find a close to accurate answer.